Right guys, next, so this is question page 126 of the DCG workbook. Question 2, we're not for question 2. So the container shown below is used for storing sweets at a pick and mix counter. The main part of the container is constructed from one sheet of plastic, the lid is separate. So, draw an end view of the container and construct a one-piece surface development of the solid. Ignore the lid for this second part of the question of the drawing. Determine the true shape of the lid. Okay, so what we're actually going to focus on first of all, guys, is just drawing the end view, and at this point, as far as I'm concerned, you should have no problem with this. So I'm going to steam on ahead with this. Okay, second part of the question, it says we have to draw a one-piece surface development of this solid here. However, if we just look here at the right hand side of the question, and I'll just try and keep it all in one shot if I can. There we go. Okay, it's saying we have to draw a surface development of this structure without the lid. So we're just going to excuse the lid, take the lid off, and it's just this structure on its own. So if we break down the structure, we can see it has the bottom, it has a back, it's got a top, and then it's got a side that actually, it's not just a side and a front. The side kind of flows the whole way around into the front. Okay, so there is a couple of ways we could do that. So starting off, what I'll actually start off with is, using red pen, construction lines, take my baseline all the way over, and what I'm actually going to do is I'm going to start with the back because we know that is a true shape. It's the exact same shape as this surface right here, this rectangle. So starting with that, take my measurement from there. It's working out to be 41. So I'll pick a start point. I'm going to pick it roughly here. I'm going to do 41 millimeters right there. Do a line up. And do a line across. And there's the back. Now I've also got a top surface here as well. And this top surface is going to attach on up here above it. So top surface is going to attach on at the very top of it. So if I imagine that was going to be up here. Now, how do I know the width of it. How do I get the length of it going in this direction? Well, the width is the same here as it is there, but the length of it is from here to here. So that's my true length there. And I know that's a true length because as I look down on it, that line there is parallel with the XY line, which means it's a true length. And it's also a true length up here. So if that's the case, then I can take that directly from it. Just measure it. And in this case, it's working out to be 29. So I'll measure up 29. Okay. Now, top, back. Now I'm going to do the base, which is the bottom. And the bottom is down here, which is essentially the exact same shape as my plan view, only without the line. It's basically like taking him and twisting him over here to fit it. So put him down here. Exact same thing. Going to measure this distance from here to here. I'll actually take that on my compass this time. from here, mark it down. Straight away, I can just mark that there. And in the middle of that, I can take this point here. That'll get me in the middle. There's my base. Nice and easy. So, base section, back section, top section. Now I've got the side here, and since I put it in the middle, I'm actually going to have to split it up. Because what we could do is, if I had actually this started over here, I could imagine then the side was going to fold out all the way out and back across over here. Starting here, working all the way around back across. However, in this case, I'm going to have to basically do a side all the way to the middle of it, and then from the middle all the way back around to the opposite side. What I'm going to have to do now is take true lengths. So, starting with the side, I know this much I'm going to be stepping out, this distance here, which is the same as that. So I can take that distance on my compass. So, taking this distance on my compass, from here to here, I'll just mark it below as well. And if I do it on one side, I should also do it on the other. Mark it there. I'll extend that line over in a second. Mark it there. Okay. And now I also have a straight line section going from here to here. And I can take that also as a true length. The reason I can take this bit here as a true length and not this bit is because this bit isn't a true length. This is parallel in plan with the XY line. So if it's parallel with the XY line in plan, that means it's a true length in our elevation. Because it's actually not parallel in elevation, but it is in plan. So I'll take that distance and I'm going to just step that out here and step it out here. There we go. Somewhere down along there and there should be my points. Now, so at this point here, which was this and this, I'm actually going to use a letter here. Sorry, at this point I'm going to use a letter here and I'm going to say this is A, which means that this point here is A. And this point here is also, well, depending if that was A there, I'm just going to say it's A as well. Now, I know the distance to 1, or 7 if it's at the other side, over here, is this distance away. And if A is there. However, it's that distance away. What I have to do is, I can take the true length of that here. Because that is my base in plan. That is on the ground. Take that distance there in plan. And what I'm going to do is I'm going to mark that out. So if that's 7, sorry, this was 7 here, and 6, and 5, and 4. And it'll be the exact same at the opposite side. There, there, there. 1, 2, 3, one more I think it is. Yep. There we go. Now, this is where it gets slightly tricky. So, if we had A here, which is there, and our A is here, which is here down below, should label it, that's why I was getting confused a minute ago, and somewhere out along this arc is going to be 1. So 1 was here, we marked off, we stepped down 7 to 6, which is the same as the distance from 1 to 2. okay, which were coming from A here and A here. So we took that distance as a true length, and then we also took the distance from 7 to 6 as a true length. Now, in reality, that there, because that's on a slope, we couldn't really take that as a true length, but we also know it's the same in plan. So that one there, when it's in plan, that is actually a true length. So we took that distance, 7 to 6, and we stepped it off. So if A is there, this is 7, then it goes to 6 to 5 to 4. 6 to 5 to 4. Then it goes from A here to 1 to 2, 3 to 4. Now it's just a case of locating the rest of our points. So 7 was directly up here, 6 is going to be up here, 5 is going to be up here, 4 is going to be up here. The exact same thing on the opposite side. 4, 3 will be a bit higher, 2, 1. And it's just a case of finding them. There's that one, and that one. 2 and 6, bring them across to there. And 4. There we go. So, to locate them exactly, 1, 2, 3, 4. Curve, 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 curve. So I'll just heavy those in. Okay, now the last part you might assume is a curve as well. However, that last part is just a straight line, because that wasn't actually part of it. There we go. Now, for the sake of it, I'm just going to call that the side, and this is the same side. I won't say side 1 or 2 because they actually mesh in together. Okay, last part of the question, it says determine the true shape of the lid. Now, there's a couple of ways we could actually do this, but if we imagine, if we come back over here, I'll come away from the surface development for a second. Now, elevation and elevation plan, and what we have is a lid here. That's not the true shape because we know it's tilted at an angle, and this isn't a true shape either because once again it is tilted at an angle. The only way we can see the true shape of it is either to do an auxiliary, which is where we could project it up here, do an x1, y1, and when we project from the elevation we would take our depths down from the plan. That's one way you can get the true shape of it. Another way, and probably a little bit of a quicker way, would be to get the true shape of it by literally just taking the lid and rotating it up. So the hinge point is here, so if we imagine the lid was there, and literally it's just rotating up. And what we want to see is the bottom of the lid, which is down here, rotating up, and when we're looking down on it and projected, imagine the lid is up here on this line now, which this is the hinge, so I'll just write in that there, the hinge. Okay, what we're going to do is we're going to rotate it up. And we have various points on that, so we take A as the hinge, we got A on both sides, because we got A here and here, and I'm going to rotate up all these points, but the main one here being 4. So that one there, 3 and 5, there, this guy, and this guy. All rotated up. Now, technically, 4 has gone from here to here. 3 and 5 are now here. 2 and 6 are up here. And 1 and 7 are here. Okay. And in this case, all we're going to do is we're going to bring 4 down. If we imagine the lid was literally just rotated up, 3 and 5 down, 2 and 6, and 1 and 7. And what I'll actually do, just to give it a little bit more clarity, it's like I'm after taking the lid up there like that, and he's after basically moving up like a door. Now, to locate those points exactly, it's just a case of wherever they were in plan, he's now moved from here across to here because it's literally just rotated up. So 4 move from here over to here. So all I'm going to do is bring 4 out. And there's my new 4. Bring 5 and 3 out. 5 and 3. Same with 2 and 6. And 7 and 1. Okay. And locate the new points. There. Just make sure I get the right ones. Here. 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 And here. So it's literally a case then. I'll do this in pencil first. Now, in my opinion, that's a little bit quicker than doing the auxiliary, but recognizing you have to recognize it. And just use color there as well. Go over the blue. So, true shape is now here. And all the way up to there. And that there, guys, is known as the rebatment method, where I literally just rebatted it up, rotated it around. So that is my true shape. I just rotated the door up. The other way, as I said, we could look at the true shape, or sorry, we could look at the lid as an edge view, which is when we see it as a line, and look perpendicular to that, bring it up here, x1, y1, and then from there bring up all my points, obviously A1, 7, 2, 6, 3, 5, 4, up here like that, and take my distances down from the XY line down. So I take to get A here, I'd take this distance, and to get the A at the other side, I'd take that distance. And you'd end up coming out with the exact same shape. Okay.